All right, we're talking about triangle similarity today. So let's get right in on this here. Um, so this idea of similarity. Let's just talk about similarity first off. Similarity just means that you've got the same shape, um, but different size of that shape. It doesn't. It's got to keep its same, the exact same shape. Like I say, it's just a different size when we've either enlarged or reduced it, when we did with our dilations. And so how we know two things are similar is by two things. We look at their angles, um, and it doesn't just have to be triangles, like it could be any shape, but all the angles have to be the same, or the corresponding angles have to be the same. The same measurement, I should say. Okay, so what I mean by that is, like, if this angle B corresponds with this angle N, then they have to be the same. But for this triangle, all three of them do. If I had some sort of quadrilateral, like a four-sided figure, then we'd have four angles, and the corresponding angles would all have to be the same. Why I say corresponding is that A does not correspond with N. So, like, it's the ones that are in the same position is what we mean by that. So that's the first thing. All angles have to be the same. And then all side lengths they have to be proportional. And what we mean by that is they all need to either grow or shrink at the same rate. Okay? They have to be, again, what we call proportional here. Okay? So what I've got here is I've got a triangle here that we know is similar. Because if I look at this, I've got all my angles are the same. This are the corresponding angles. So 70 and 70. C and O are the same. And then A and M are the same. This little line here means they're the exact same. I don't know what the angle is. Well, it's going to actually be 40, but this little mark tells me they're the same. So it checks off the first thing. And then the second thing is that all sides have to be proportional. So to check that, I need this side A to B, and then its corresponding side, which is 4. I'm going to divide those. Okay? That's going to give me 2.5. And then I need the next side, so A to C and M to O, which would be 10 over 4, and that's pretty obvious that's going to be the same. The one for this triangle that we really got to check is this one here, which we're going to do B to C over N and O. So this is just how you check it. So 3 divided by 1.2, which is 2.5 as well. Okay? So as long as all these are proportional, then we're good. As long as these are all the same. If one of them is off just barely, like if it was 2.48, then they're no longer similar. There's something that's just slightly different about them. Okay? So all angles and all angles have to be the same. All sides have to be proportional. That's how you check and see it. Now triangles are kind of special, guys. Triangles, because this gets kind of tedious. I mean, if you have to check every side and every angle, sometimes that's just not doable. Triangles, we only need the right information, okay? And so there are 3 rules that we're going to talk about here. And please don't get this confused with congruency. Last year you guys talked about congruency, and congruency means that they're the exact same. This is similarity, which means the angles have to be the same, the sides have to be proportional. So for triangles, I just need the right information. So I need some of the following. If I have 2 angles, so if I have 2 angles, then and they're the same in this triangle. So for example, if I had, let's say I had these 2 triangles here, obviously not the exact same, but let's say I had this angle was congruent to that angle, and then I had this angle and this angle. These 2 would be similar because I know this angle is the same as that, and another second angle is that. So we need two angles. I don't need, if I have two angles and I don't know anything else about the sides, then we know they're similar. So that makes that nice. I don't have to sit here and measure sides or know anything about sides. If I just have two angles, we're good. Okay? So that's one of the rules. They call that, again, angle, angle, or we'll use AA here. Okay? The next one is to have all three sides be proportional. And again, some of you guys are thinking, well, I've seen this already. It's not, because you're talking about congruency. Okay, so side, side, side with this one. So how that one would look is if I had two triangles here, and I knew, that's not very good, that's okay. Let's say I had this as 2, and this is 4, and this was 3 here, and I had those, and then this side was, let's say 4, this side was 8, and this side was 6. If I go to divide each one of these, they're all increasing by timesing by 2, and that's all I need to know. I don't need to know anything about the angles. So again, that's why triangles are special. I only need the right information with triangles. So angle, angle, or side, side, sides have to be proportional. Again, they have to be proportional here. And then the third one is a side, and then the angle that's included. So what I mean by that is this. So if I have, let's say I know that this side right here is 3, and then I know this angle, and then I know this side over here is 3. So this would be side, angle, side. And again, that angle has to be in between the two sides. It can't be over here because that's not in between. And this is what we call side, angle, side. And the sides have to be proportional. So if I was looking at this other one over here, say I've got another triangle over here, I've got this at, let's say 4, and then I know that angle in 4. It's increasing at the same rate for this side and the right side as well. So this would be side, angle, side. Those are my 3 rules, and you want to make sure that you have those down. Please remember the angles have to be the same, the sides have to be proportional, and you do need to check each one of them. So that's the idea of similarity, guys. Angles the same, sides proportional. If you get that, you should be able to do anything with triangle similarity. But let's look at a couple of just practice problems how we do this. So what we want to be able to do with this is to look at 2 triangles and with the information that they are giving me, and be able to conclude whether or not they're similar or not. And we're going to do that by one of these 3 rules. Okay. So here we go. Let's start here with this one here. So this one just says state if the triangles in each pair are similar, and if so, state how you know, and then complete a similarity statement. We'll do that in a minute. So I'm going to look at this far left one first. So this one, if I look at what I'm given side lengths, guys. These outside numbers are side lengths. And so what I need to know is I need to know whether or not these are for sure similar. So here's how I do this. I'm going to take the big side. This one's kind of rotated, and hopefully you guys can see that. This 54 corresponds with the 45, but then the 60 corresponds with the 50. So it's kind of been flipped over. So what we want to do is take the big side, so 72, and put it over the big side of the other one. And it doesn't matter which way, I just picked this one to go over that one. Then I'm going to go to the next size, which would be this 60 right here. And I'm going to put it over the 50. And then the smallest side, 54, and put it over the 45. And then all I'm going to do is I'm just going to check. I'm just going to divide those and make sure that they're all the same. They have to all be the same, okay? So if they're not, if you get through 2 of them and they're not, then you know that they're not. So this is 1.2, this is 1.2, and this is 1.2. So I would say yes, they are similar, and it's by side, side, side. Okay, because it says state how you know. How do I know? By side, side, side. And then the third thing it says is a quickly a similarity statement. A similarity statement is this. It's just saying that triangle, let's go T, V, U, and then I'm going to use this little squiggly. That means similar to triangle. And then we've got to be careful. This is the part that's, you got to make sure your similarity statement's right. So T corresponds with what vertices? So T is right here between the second and third length, so that would be C. Okay, and then I went to V, so V goes up that shorter side, so that means I've got to go to the shorter side on this one, so that would be A. So C, A, and then B would be that one. There's my similarity statement. Okay, let's do a couple more of these. So if I look at this next group has no sides. I'm being given angles here. And so I have D, which is the same as S, and then I have E is the same as R because of the 3 lines here. So I know this is similar. So this would be yes. And again, by angle, because they're both the same. And then my similarity statement, I'm going to go triangle. Again, if I start up here, that I'm just going to go D, E, and F. And then similar to triangle, if I start at D, S is the one that I have to start with, this one. And then I went to E, so I've got to go to R, so S, R, Q. And that would be my similarity statement. Angles are sweet because you just got to look and see if they're the same. You don't have to check the proportions. Okay, looking at this last one here. I've got 2 sides, but remember I've got angle, side, 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 or side, angle, side. So this one's, the only possibility would be side, angle, side, because I've got the 2 sides that they're given to me. Which, I also have an angle, guys. If you guys remember back to our lines and intersecting, these 2 angles right here are the same because they're vertical angles. So I have side, angle, side. That's my possibility. I just need to check and see if my proportions are the same. So I'm going to take this smaller side here, so 9, and divide it by the smaller side of these 2, which would be 6. Again, don't do the 12. And then I'm going to take the 18 and divide it by the 12. And I need, again, I need those to be the same in order to have this be similar. So this I get 1.5, and this one I get 1.5 as well. So that's good. My 2 sides are proportional. My angles are proportional. So this would be yes, again, by side, angle, side. And then my similarity statement, I'm just going to start with this. I'm just going to go JLK, so JLK, and then put the little squiggly, similar to triangle J, because they share that same vertice. I want L, so I need to go down the small side on this one, which should be E, so JED. Okay? Hopefully you guys are getting an idea of this. Let's do a couple more here. So if I look at this pair, again, this is side, angle, side, side, angle, side. Make sure that angle is between. If it was down here, we couldn't do it, okay? So for this one, I've got to look and see if my sides are proportional first. So I've got 10 divided by my smaller side, which would be 99, and then 12 divided by 121. And I'm just going to check and make sure those proportions are right. So 10 divided by 99 and 12 divided by 121. So I get, for this one, I get 0.101, blah, blah, blah. This one I get 0.991. So see how they are different? I don't even need to finish this one. I'd say they are not similar because, again, because of these proportions not being the same. So I'm done with that one. They're not similar. Okay, go to this next one here. This one has 3 sides for both these, so I've just got to check the proportions on these. So I'm going to go 42. Again, that's my small side divided by 6. Then I'll go to my next smallest, so 72 divided by 12. Again, these are kind of rotated, so it's easier just to go small, medium, and large sides. And the next one, we've got 78 divided by 13. So all I'm going to do again is I'm going to check these again and make sure that they are good here. Okay. Well, right here. So this one I get 7 right, and this one I get 6. So I don't even really need to check this last one, truth be told. This one does give me 6, but see how they're not all the same? So this is not similar, and if they're not similar, I don't need to write a similarity statement at that point in time. Okay? So that's what I'm looking for you guys to be able to do, is look at two figures and know if they are or not. So the only way on those triangles to do that is by those 3 rules. Angle, 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 side, 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 or side, angle, side. Our angles are the same. The sides have to be proportional. Please be careful with the side, angle, side. That angle has to be in between for these, okay? Like, it can't be over here. No bueno. It can't be to the side at all. Okay? Math moment with Mommy out.